Hello everyone, my name is Xiang Sun Cheng. I come from Shanghai Jiao Tong University. Today, I'm going to talk about unsupervised domain adaptation through statistics for person identification. So what is domain adaptation for person identification? Well, it's about performing training and testing in different domains. For example, a model trains on Duke dataset while testing a market dataset. Note that the training and testing are in different domains, and this gives rise to domain adaptation for person identification. Well, there are several challenges we need to address for this unique task. The first one, the existing dataset for person identification are always in small scale. Actually, there always lack of diversity in viewpoint, weather, emulation, and poses, which can always lead to overfitting problem during training process. So how can we solve this problem? First, we construct a large-scale statistic GPR dataset, which consists of 754 identities. And each identities have configurable viewpoint, weather, and time distribution. So an attribute for each identity can be edited as you want. So this allows to all datasets to be highly flexible and extendable. Second, based on all proposed GPR datasets, we also design a unique domain adaptation framework, which consisting of IBNet and SAMSCAN. To be more specific, for IBNet, we just made a steady modification based on REST 15, which is a widely popular network for feature extraction. Then we integrate IN and BM and building block to the first three groups of REST 15. In particular, we named the first group as before without any change. That's the detailed architecture for IBNet. Actually, for our SAMSCAN, we also made a slight modification based on CycleGAN, which is designed to perform image-to-image translation in an unsupervised manner. To be more specific, we integrate our SAMSNet with CycleGAN to performing image similarity preserving learning. Especially, the CycleGAN is designed to learn a map action between source and target domain, and SAMSNet is designed to learn a net space constrain the map action between source and target domain. So, what is the result with this SAMSCAN? So, we'll give some visualization results. As you can see, it can, with all CycleGAN, it can be easily found that it has a lot of noise within CycleGAN to performing image-to-image translation. However, with all SAMSCAN, the transformed image have much more qualities, and the results even close to market dataset. Here we also need some other results when performing transfer learning from GPR to market datasets, as well as GPR to Duke datasets. And these visualization results demonstrate the priority of all proposed SAMSCAN. Well, how the performance was all designed domain adaptation framework. Actually, with the CycleGAN, we can only achieve a required accuracy of 73.6%. However, with all SAMSCAN, we can achieve a required accuracy of 76.1%, and which leads to a significant improvement of 2.5% when performing testing on market datasets. If we perform testing on local datasets, we can also achieve a significant improvement of 1.8% in rank 1 accuracy, which verifies effectiveness of our proposed domain adaptation framework. Here we also list some detailed comparison with our existing method. So from this table, it can be easily observed that with our proposed domain adaptation framework, we can always achieve state-of-art results comparing with existing approaches. So our approach is definitely a phenomenal job in person identification task. So let's make a conclusion. First, we create a large-scale statistic and device person identification datasets named GPR, which have a large variety of diversity and a large number of identity. The size of this dataset is controllable and extendable to person identification area. Second, we also propose a novel domain adaptation framework to further boost performance for unsupervised person identification tasks. It's definitely a phenomenal job for person identification area. So in the future, we continue focus on domain adaptation identification task based on our proposed statistic GPR dataset. And second, we will continue to explore how to extract more effective domain invariant feature between statistic and real-world datasets. We hope all this work can provide a significant guidance to further research in this person identification area. So that's all my report, and thank you for listening. That's all. Thank you.